All right. Good evening to you all. You're welcome to today's class, today's session. For those of you who are joining us for the first time, this is a Cisco CCNA1 class, Introduction to Networking class. And if you are not in the WhatsApp platform, please try and join the link. By the end of the class, I will also drop the link on the chat for those who probably are not in the WhatsApp group. Additionally, for those who have not followed our enrollment link or who have not watched or were not part of the introductory class, I encourage you to check the YouTube link, which I will still post on the WhatsApp group again. To those who have not watched, please do so to watch so that you'll understand what this course is all about and the rudiments of the course. Today, we'll be looking at Module 1. Module 1 with the topic Networking Today. Networking Today. Okay? Now, we will be focusing on different aspects, but we are starting with network components. All right? When we say network components, we are talking about the items that makes up a network. When you say a network, you are trying to say it is an interconnection of two or more end devices that are connected using a medium in order to share resources. So every computer on a network is called a host or an end device. So anytime you are forming a network, there must be end devices. Like you see, this is an end device, this is an end device, and they are connected through a medium. They're forming a network. Now, we can have setups such as a server and a client. A server is a dedicated computer that provides special services to clients. Okay, so servers are computers that provide information to end devices. Information could be like the email servers or services, or the web server, or the file server. The email server runs email softwares, so clients use their client softwares to access that particular email. The web server runs web server software. So clients use browsers to access the web pages that are in that particular server. So generally, you have a server and a client, and in each case, there is a need. One is making a request, and the other one is providing the services. Okay. Now, another type of network is what we call the peer-to-peer. So this concept of roles is to let us know that there is, to set up a network, you need an end device, you need a network medium, and you need an intermediary medium. But in this setup where you have peer-to-peer, you need the end devices, you need a network medium, but you don't need an intermediary device because it's like a setup that connects just two end devices together. So it is possible to have a device to be a client and a server, in a peer-to-peer. So this system can be a server and can be a client. This can be a server and can be a client as well. And what are the advantages of that? You have easy to set up, is less complex, is lower cost, and used for simple tasks, probably maybe for transferring of files, from one system to the other. And the disadvantage is that there is no centralized administration, especially when you have multiple devices that are in question. And it's not as secure as it's expected. And it's not scalable. It's not scalable means that peer-to-peer cannot expand. You are just forming like two systems, you connect them together. But once you begin to have 5 systems, 10 systems, 20, 100, 1,000, how then can you set that up? It's not actually good for it. So it also has slower performance, okay? So an end device is where a message originates from or where it is being received. So data originates with an end device, flows through the network, and arrives at an end device. So end devices could be your desktop, could be your mobile phone, could be your IP camera, could be your server, could be whatever device that actually generates the message from, or it is the destination. So you see, you have an end device, then you have an intermediary devices. All these are intermediary devices. Then you have your network medium. So that forms a network. Now, intermediary devices interconnect end devices, examples of which includes the switches, the wireless access points, the routers, and the firewall. Okay, so these are intermediary device, this wireless access point. What it does is that it provides wireless access to laptops, phones, or any device that use Wi-Fi, okay? LAN switch is also an intermediary device because it is a multi-port internetwork device that actually helps to connect multiple devices through a central point. So if you are looking at a centralized system, a switch comes into play. Then you have the router. The router is an intermediary device that does path determination and packet forwarding. So once ever your traffic comes and is going to a destination, it's the router that determines which way to forward the traffic. Then you have the multi-layer switch, which is actually like a switch, but it's called multi-layer because it works at two different layers or more than one layer. We'll get to talk about what those layers are. Then you have what they call the firewall appliance. So you see, all these devices are not like the source or the destination of your traffic. In most cases, they control the flow of the traffic. The traffic comes through them, and then they make certain intelligence decision. They regenerate and retransmit the signal. They maintain the information about what pathway exists, and they notify other devices about errors and failures, you know, and then they decide how the traffic moves and so on and so forth. So basically, that is their work. So then you have the network media. Okay, communication across a network is carried through a medium which allows a message to travel from one source to a destination. Okay, we have different network media. We have what we call the copper media, the optical media, and the wireless media. What is the difference between these mediums? Okay, the copper media is actually a network media that is made up of copper wires, and it carries data in form of pulse, electrical signal, okay? And the most common types are what we call the Cat5, Cat6 cables. You see them, they are the LAN cables, okay? So they convey data in form of electrical signals. The next one is a fiber optic, and it's known for its high bandwidth capability. It can carry very large volume of data, and it can go a very, very long distance. The copper one can actually go about 100 meters or thereabout, but the fiber optic can go 2 kilometers, 3 kilometers, 5 kilometers, even 10 kilometers, depending on the type, okay? But it carries data in form of pulses of light, okay? And the fiber optics comes in two types. There's what we call the single mode, and there's what we call the multi-mode fiber, right? Then you have the wireless medium. The wireless medium uses modulation frequencies in order to carry data. So it carries data in form of electromagnetic waves. Okay, that's how it carries data. Now, each of these medium, you use one of it whenever you are setting up a network. So it tells us again, when you are setting up a network, you need your end devices. Okay, you need your end devices, you need your intermediary devices, then you need your network medium. All right. Now, whenever you are designing a network or you are representing a network, there's what we call topology. Topology actually gives you the layout of your network. And we have two types of topology. We have what we call the physical topology, and we have the logical topology. The physical topology illustrates the, how do I put it, the physical way in which these devices are actually connected. Okay, it expresses how the end devices physically connect to the intermediary devices and so on and so forth, and to which port and how they are connected. Basically that is it. So, but the logical topology illustrates how the traffic passes through. Okay, and illustrate like ports and then the addressing scheme of the network, maybe the IP addressing of the network and things like that. So it focuses on, how do I put it, behavior of the traffic, how it passes, and using IP, while the physical topology is based on the cabling and how the devices are physically connected. Let us look at some common types of network. We have what we call the small home office, a small home network. That one connects a few computers to each other and the internet. Then you have the SOHO, which is the small office home office. And what it does is that it enables computers within a home or remote office to connect to a corporate network. Then you have the medium to large network. Many locations with hundreds or thousands of interconnected computers is where you have this medium to large network. Sometimes they call it LAN, sometimes MAN within a metropolis, and so on and so forth. Then you have the worldwide connection or network, which connects hundreds of millions of computers worldwide, such as the internet. Okay, so those are the different types, and you can represent them in form of what they call LAN, wireless LAN, MAN, and WAN. Okay, so we'll look at them very soon. Now, for the LAN and the WANs, basically, the LAN is an interconnection of devices within a small geographical area, okay, under a single administrative domain. And you can determine that by the size of area covered, which is for LAN is a small area. In case of WAN, it is a wider area. And then the number of users that are connected. For LAN, you have a small user. For WAN, you have a wide number of users. Then you have what they call number and type of services available. Okay, between WAN and LAN, there are different services. Then you have area of representatives. Okay, so you could see that in this small office, this is this home office, this is a LAN. You have a router, wireless router connected to the TV, to the printer, to the system. Okay, then you have a branch office here, which has another LAN. You have an intermediary device. You have devices, IP phones, servers that are connected. Then you have another LAN here, which is the central office. Okay, somebody is saying that my screen is not visible. I don't know. Okay, I think my screen should be visible. If you can see my screen, just send a message on the note on the chat. Let me know. Okay. All right. So I can see confirmation that the screen is visible. Thank you. Oh, all right. Clear and visible. Okay. Thank you very much. All right. Okay. So basically, that is it. The concept of the LAN and the WAN. So you see that the WAN in this case actually interconnects LANs. The WAN interconnects LANs, and then the services that the LAN does in order to interconnect the WANs are very interesting. By the time we get to CCNA3, we're going to be focusing on this WAN aspect. Okay, we'll be focusing on the WAN aspect. Good. Then, a LAN is a network infrastructure that spans a small geographical area, while a WAN is a network infrastructure that spans a wide geographical area. So a LAN interconnects N devices within a limited area. So this is an N device, this is an N device, and that is it. But a WAN interconnect LANs over a wide area. You could see that this is a WAN, so it interconnects this border router with this one. Okay, so that is the setup of the WAN. So a LAN is administered by a single organization or individual, while a WAN is typically administered by one or more service providers. Okay, then you have a LAN provides high-speed bandwidth to internal devices, while a WAN provides slower speed links between LANs. So that's some of the differences between them. How about the internet? What is this internet? Okay, the internet is just two words brought in together, inter and net. So inter stands for interconnection, and then net stands for network. So you have interconnection of networks. That's the internet. So the internet is a worldwide collection of interconnected LANs and WANs. So LANs are connected to each other using WANs, and WANs may use copper wires, fiber optic cables, and wireless transmissions as well. So the internet is not owned by any individual or group. The following groups develop to maintain structure on the internet. Okay, so you see this is a home LAN, this is a hospital LAN, this is a government LAN, this is a business LAN, this is a school LAN, and so on and so forth. But you see that they are connected together amongst themselves. So this connection, interconnection, is what we call the internet. So you see that it's not like one person owns the internet. No, no single person owns the internet. Okay, it is like everybody is a shareholder. But there are organizations that helps in the management and control of what happens on the internet. And part of them is the IETF, which is the Internet Engineering Task Force. We'll talk about them later. The IETF, okay? Another agency or organization that controls internet is the ICANN, okay? Then you have the IAB. We'll talk about them very soon. Now, still talking about types of networks, we have looked at LAN, we have looked at WAN, we have looked at internet. Then now we want to look at intranet and then extranet, okay? An intranet provides collection of LAN and WAN internal to an organization that is meant to be accessible only to the organization, very key, only to the organizational members or others with authorization. That is the intranet. So this is like the intranet, company only. It's like saying you go to a bank. The bank have an intranet service because the application that they are using in that particular bank, you don't have access to it. And no matter where you go, you don't have access. It is limited within the banking environment. Okay. Then you have what we call the extranet. Okay. The extranet is like a portion of the intranet is provided. Okay. So it's like the bank has an app. The bank has an app. So if you're using maybe GT Bank or Zenith Bank or First Bank, you have an app that the bank provides. So that app provides like an API or a gateway where you can connect to the intranet resource. Okay, so that kind of setup is the extranet. Okay, sometimes you have suppliers, customers, and collaborators that want to relate with the intranet service, so they are being given a particular exclusive access or portal where they can be able to do that. Then an organization might use an extranet to provide secure access to their network for individuals who work for different organizations that need access to their data on the network. Okay, so that's the importance of the extranet. Then you have the internet, because the internet now connects different LANs. How about internet connections? How do you connect to the internet? There are actually many ways to connect users and organizations to the internet. Popular service for home users, you use this small office broadband router, so you can just carry your SIM router and you are connected to the internet, or your MiFi connected to the internet. Okay, or some people actually connect using DSL, digital subscriber lines, or they connect using Starlink. Some people even connect using fiber to their homes, but it's not very popular in Nigeria. But other countries, you have fiber down to your home. Others use maybe wireless technology, maybe radio in order to make this connection. But the point of internet access is who provides you access to the global world, to the outside world. So the person that provides you that is your internet service provider. So organizations need faster connections to support their IP phones, to support video conferences and data center storage. Everybody needs access to the internet. So business class interconnections, are usually provided by service providers, that may include maybe MTN or Glo or Airtel or any of these service providers. Or you could even have them connect you through lease lines or DSL or Metro Ethernet. The point we're making is that you can connect either using cable or wirelessly, okay? And the companies, the ISPs know what to do. So, like we said, the cable connection gives you a high bandwidth and is always on, and the internet is provided by maybe a cable company or so. So mostly organizations use that. So maybe if you go to your office, or if your office is big, you may have a fiber end-to-end connection to your organization. Okay, that is maybe how you get your internet. Or you will use what we call DSL, digital subscriber line. Gives high bandwidth, always on. Internet connection runs over a telephone line. And that one, usually we connect during the time of nighttime. You see, where you have telephone and you can use your telephone to connect to the internet, or where you are using DSTV and there is a way you can set up your DSTV so that you can gain access to internet and things like that. Okay. Then you have the cellular technology where you use your phone. If you pick up your phone and you can open your hotspot on your phone, and then you gain access to the internet so that your system or your devices will be able to connect. Then you have the satellites. All right, satellites major benefit are rural areas. An example of it is the Starlink. Okay, you can get Starlink, or there's what they call the VSAT. Okay, the whole idea of the satellite is that it's pointing to a particular device in the orbit. Okay, then you have the dial-up telephone. We don't usually have this one now, but in the past, the dial-up telephone is what you use to connect to the internet. Okay, now, but for organizations like your schools, your companies, you need higher bandwidth and you need dedicated connection. And For you to do that, you need what we call the lease lines. Okay, lease lines is like a reserved circuit within the service provider's network that connects distant offices with private offices. Okay, or you need the Ethernet WAN that extends the LAN access technology into WAN. Okay, now having known that, previously, when computers are set up for people to gain access to the internet, if you want to watch video, you may have to turn to NTA, or you have to come and put a dish in your house where you watch video, maybe DSTV or satellite dish or whatever free to air you need to do to watch video. If you want voice, you have to put a telephone line in your house, telephone line where you're going to make calls and things like that. And if you want to browse the internet, maybe you need to go to a cafe, or you need to just do. So you see, each one of them is different. So before converged networks, an organization would have been, separately cabled for telephone, video, and data. And each of these networks would use different technologies to carry signals. All right. Each of these technology will use a different set of rules and standards in order to carry that. So that was what was going on until we have what we call a converged network. A converged network is where your voice, your data, your voice, your video are all carried on a single channel. So if I pick my phone, for instance, I can make calls on the internet. I can stream video on the internet. I can browse data on the internet. So that's a converged network. A converged network is where you have voice, video, and data all conveyed through one channel or one medium. So it can deliver data, voice, and video over the same infrastructure. And the network infrastructure uses the same set of rules and the same set of standards. It's not like the other one that it has different rules and standards, but this one is the same, and that's why it's called a converged network. So, what is a reliable network? And how can you set up or build a reliable network? All right. Network architecture refers to the technologies that supports the infrastructure that moves data across the network. Okay. So we have what we call the 4 basic characteristics of network architecture. If you are building network, you need to address these 4 basic elements. Then your network has to have fault tolerant in order to be called a reliable network. Fault tolerant, it must have scalability, it must have quality of service, and it must have security. Now, we're going to look at each one of these one after the other. When we say a network has fault tolerant, what does it mean? A fault-tolerant network limits the impact of a failure by actually limiting the number of affected devices. So when you have multiple paths that are required for tolerance, reliable networks provide redundancy by implementing a packet switch network. Okay, so packet switching splits traffic into packets that are routed over a network. So each packet could theoretically take a different path to a destination. So we are saying that in a fault-tolerant network, you are creating redundancy. Between the source and the destination, it is not only one road that leads you to the destination. Once you hit the road, you can have multiple paths. So you could say part of this traffic will follow this road, another path will follow this road, and things like that, but they will all assemble and reach the same destination. Okay? So your network, as you are building it, should be fault tolerant, should have redundancy. The second element in network architecture is scalability. if you are building a reliable network, it needs to be scalable. Scalability means the ability to grow. Okay, your network can expand quickly and easily to support new users and applications without impacting the performance of service to the existing user. Very, 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 very important. Okay, so network designers follow accepted standards and protocols in order to make the network scalable. Okay. Another element in a reliable network is that it has to have quality of service. Now, remember, we have talked about a converged network. It is because we have a converged network that the idea of quality of service came to play. So voice and live video transmission require higher expectation for those services being delivered. So have you ever watched a live video with a constant breaks and pause? This is caused because there is a higher demand for bandwidth than available, and quality QoS is not configured. So idea of QoS is just priority. It's like somebody is on a convoy. You people are all moving, and then there's somebody on a convoy with a siren. You will see that everybody will give road to it because it has a higher priority. So in a quality of service, it is primarily a mechanism that is used to ensure reliable delivery of content to all users. So with quality of service policy in place, the router actually can move, easily manage the flow of data and even voice traffic. Then the fourth element for a reliable network is network security. There are two main types of network security that must be addressed. Okay, the network infrastructure security, which talks about the physical security of the network devices, preventing unauthorized access to the device. Information security is another, which talks about protection of the information or data transmitted over the network. So three goals of network security is confidentiality, integrity, and availability. We call it the CIA. So when you are setting up your network, you need to consider security. All right? You need to consider security very, very important. How about network trends? What are these network trends? Okay. The role of network must adjust and continually transform in order to be able to keep up with new technologies and end user device as they constantly come to the market. So several new networking trends that affect organizations and customers include: one, bring your own device. What is this BYOD? BYOD is saying that there are organizations that say anybody can come with his own device, whether it's a phone, whether it's a tablet, whether it's a desktop, whether it's a laptop. We can configure and connect you to the network. That is it. And it's a trend that is doing well. Another trend is what we call the online collaboration, where you have people around the globe are collaborating with each other on a particular topic or a particular issue and things like that. Then you have video communications, okay? Then you have cloud hosting, okay? Okay. Cloud hosting. Sorry, I was just checking the message somebody sent. Okay, so we said bring your own device, allow users to use their own devices, giving them more opportunities and greater flexibilities. BYOD allow end users to have the freedom to use personal tools to access information and communicate, using their laptops, their notebooks, their tablets, their smartphones, their e-readers, and so on and so forth. So BYOD means that any device with an ownership with any ownership, used anywhere, can be used. So it's a new trend that is working. Another one is the online collaboration, all right, where you collaborate and work with others over the network on points projects. Maybe you have a project and you have something to work on, and then you guys can collaborate with each other online. So the collaboration tool include maybe like the Cisco WebEx. It can give users ways to instantly connect and interact. Collaboration is a very high priority for business and in education, because no man is an island. You cannot claim that you know it all, okay? So collaboration is very, very important. Then video communication. Video calls are made to anyone regardless of where they are located. So video conferencing is a powerful tool for communicating with others. Video is becoming a critical requirement for effective collaboration, right? Cisco telepresence power is one way of working where everyone, everywhere, right? Another trend that is very important now is the cloud computing. Cloud computing allows us to store personal files or backup data on servers over the internet. And you find out what is cloud computing. It's just you are computing in the cloud. When you say the cloud, you don't mean the physical cloud up there. No, it basically means that you are hosting your data in another computer remote from where you are. Okay, that is cloud computing. Now, cloud computing is made possible by data center. So smaller companies that can't afford their own data centers lease servers and storage services for larger data center organizations in the cloud. Okay. We have 4 types of clouds. We have the public cloud, which is available to the general public through a pay-per-use model or sometimes free. Example of them is like your OneDrive or your Microsoft Google, Microsoft OneDrive or Google Drive or Dropbox. They are all examples of public clouds, even your Gmail and things like that. Then you have private clouds, and it's intended for specific organizations or entity such as government. So there are certain resources that government are using in the cloud, but you cannot find in the internet, okay? Or even banking institutions. You cannot find their data on the internet because they're using private cloud. Then you have the hybrid, where you have partly is private, partly is public. So made up of 2 or more cloud types. So for example, part custom and part will be public. So, and the next one is the custom cloud. The custom cloud is built to meet the needs of a specific industries, such as maybe the healthcare or the media, and it can actually be private or it can be public because it's custom. So it's based on what is being needed. Now, still talking about the network trends that are happening, we have technology trend in the home, okay, where you have smart home, or you have smart technology, you have smart cars, you have smart everything, smart house, your curtains, your fan, your AC, your television, your radio, your equipment, everything is running on a network. So in that kind of setup, we call it a smart home. Okay, so it's a growing trend that allows technology to be integrated in like everyday appliance and allow them to interconnect with other appliances. Okay, ovens might know what time to cook a meal, for you by communicating with your calendar or what time you are scheduled to be at home. That's a smart home. Sometimes the moment you walk in, you discover that light comes up and then you see the radio begins to play and it tells you welcome and things like that. So that is smart technology. Another trend technology is the power line technology. All right. Power line networking can allow devices to connect to a LAN where data network cables or wireless communications are not viable, are not a viable option. So using a standard power line adapter, devices can actually connect to the local area network wherever there is an electrical outlet by sending data on certain frequencies. So power line networking is especially useful when wireless access points cannot reach all the devices in the home. So you see it's a technology that is in play where so far you have electricity in your home, you can use that same power line to convey data. And then we have the wireless broadband services where you have your telecoms, your MTN, Glo, Airtel, 9Mobile, and so on and so forth, where you have wireless broadband, as part of your internet service. Okay, they provide you with this particular service from home and so on and so forth. Then we will finally look at network security. Security threats. Network security is an integral part of networking, regardless of the size of the network. The network security that is implemented must take into account the environment while securing the data, but still allowing for quality of service that is expected of the network. So securing a network involves many protocols, okay, technologies, devices, tools, and even techniques in order to secure data and mitigate threats. So threat vectors might be external or internal. So you need to actually find a way to secure your network. External threats include maybe viruses, worms, and Trojan horses, spyware, adware, zero-day attack, threat actor attacks, denial of service attack, data interception and theft, and then identity theft. All these external threats are actually from outside, okay? But internal threats comes from within and can lead to lost or stolen devices or accidental misuse of employees by employees or malicious employees that are actually doing whatever they can. So how then do you work on it? You see, external ones come from the internet, but you have a firewall. So as a network administrator or security expert, you need to set up a firewall to protect from the threats that is coming from outside. But you have threats coming within your network. That is where you have your malicious staff or individuals. So the most difficult part of network security is managing internal threats. Okay, so a particular host may be compromised, and then it will now begin to carry out all those issues. So what security solution should we go for? Okay, security must be implemented in multiple layers using more than one security solution. Network security components for home or small office network, you need to make sure that is there. Then you have antivirus and anti-spyware softwares should be installed on end devices so that it can help to protect that particular device. Then you have your firewall filtering, all right, which is used to block unauthorized access to the network. So this is it. You have your internet, is coming in here, okay? And then this is policy, access list, policy, security you've done. This is access list, policy, security you have done. We'll talk about access list in previous chapters in case you don't know what it is. Then firewall, the firewall is there. Then you have your internal routers or your switches before it goes to your devices. So it's like a tree-like setup. So larger network have additional security requirement, things like dedicated firewall, access control list, intrusion prevention systems, virtual private networks, you know, and things like that. They are very, 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 very important. So that is that about that particular topic. So before we go into the questions, I will unmute you for questions. I will now go to a little activity that we set up. Sorry, let me. Right. So we have an activity on packet tracer, and it is the first activity that I had given you guys to be able to go through it. So this particular activity is actually just for you to be able to understand how packet tracer works, understanding the devices, understanding the medium, and how to access this particular items. Okay, that's basically what we want to do briefly, and then close. Okay, now this is packet tracer, and I dropped in a link where you can download packet tracer if you don't have the application. So I dropped it on the WhatsApp. But to be fair on those who are just joining us that probably may not have access to it, let me just quickly see if I can copy those links and drop them for you on the chat box. So just a minute. Okay, anyway, while we continue, any one of you can go down to the WhatsApp group, just copy the links, all the links, and then just drop it on the chat box here. Help them drop the links on how to join the WhatsApp group. I've dropped the link there, and then other links. Now, in this WhatsApp, this packet tracer, what you can do on it is tremendous. There is so much that you can do on it, on this particular, what do you call it, packet tracer. But the best way is to follow the instructions step by step. Once you follow the instructions step by step, I guarantee you, you will not have a problem. So this is the activity, packet tracer on network representation. It says that the objective, the network model in this activity incorporates many of the technologies that you will master in CCNA studies. It represents a simplified version of how a small to medium-sized business network might look. Feel free to explore the network on your own. When you are ready, proceed through the following steps to answer the questions. Okay? So let's continue. It says, note, it is not important that you understand everything you see and to do in this activity. Feel free to explore the network on your own. If you wish to proceed more systematically, follow the steps below and answer the questions to the best of your ability. All right, so instructions. Number 1, identify common components of a network as represented. Okay, what are the common components of the network? Now, here it says, the icon toolbar at the bottom left-hand corner has various categories of networking components. What are we talking about? Look at where my mouse is. Can you see where my mouse is? So here, there are different network components here. If you bring out your mouse to anywhere, you will see the name as it appears there. And it says, you should see the categories. You should see the categories that correspond to intermediary device, end device, and even media. All right. So if I come here, I am having network devices. This one is end devices, components. This one is connections. This is miscellaneous. This is multi-user connections, and so on and so forth. It says the connection categories with the lightning bolt represents the networking media supported by packet tracer. There is also an end device category and 2 categories specific to packet tracer. There's what we call the custom-made devices and the multi-user connections. So we're just doing like a general introduction about this packet tracer because that's what we're going to be using throughout for the lab activities. So it says list the intermediary device categories without entering into the internet cloud or intranet cloud. How many icons in the topology represent end devices? So if I come to the topology here, you're supposed to look at the various end devices. These are end devices. You're supposed to count them. And for your own sake, just count which ones are end devices and so on and so forth. It says without, all right, how many, okay, no, let's go to step 2. Okay. Step 2 says explain the purpose of the device. In packet tracer, only the server PT device can act as a server desktop or a laptop PC. Cannot act as a server. Based on your studies so far, explain the client and server model. All these questions is for your own personal consumption. It's not that I expect you to submit it. Okay? The ones that I will want you to submit, I will let you know. It says list 2 functions of intermediary devices. What are the 2 functions of intermediary devices? In this case, you see, this is an intermediary device. This is intermediary device. These are intermediary devices, things like that. So this activity is just simple. You just keep reading it to understand what you have here. Okay, so this is the topology, and you can see in this topology, this is a central office. This is a branch office. This is a home office. So you see, this is a LAN in itself in the home office. Okay. The home office. This is a branch office is a LAN. Central office is a LAN. But you see, the various LANs are interconnected. And their connection is actually talking about the WAN connection. And here, if you look at the packet tracer, you see this is the logical mode. Okay, then this is the physical mode. If I click the physical mode of this topology, look at it. You see, this is the home city. It will give me, then let's see, it will tell us where they are located. Where they are located. And then, sorry, I'm trying to make it small. Very good. Can you see this is the home city? So I'm going to click the home city and let's see what is there. If I click the home city, can you see? I just click the home city and it's giving me, this is the home office. This is the central office. This is the branch office. This is the ISP. So if I click the home office, these are the devices that are in the home office. Can you see them? They're giving us the physical topologies on how they are connected. Okay. If I come back here, I click the central office, it's telling me this is the main wiring closet. If I click the main wiring closet, these are the devices that are there. Can you see? This is the servers. Can you see the servers? This is the cable. This is a printer. You see, these are the details that you can see there. Okay. Right. So now we are just going through the physical topologies. These are the cables. All right. These are the switches, the intermediary devices. This is the switch we can use here. Okay. We can go back again, can come here and click and see what is here. So you can play around with it to understand the topology. You can go back to your logical topology. This is the logical topology. So I can click the internet and see what is there. If I click the internet, this is what is there to tell me that this is the cable service provider. This is the ISP tier 3. This is IT tier 3B. And then this is the DNS and things like that. Okay. So I think it's good for, it will be very interesting that if you take time to check this thing out. This is the ISP. If I check the equipment room, I will see. It's just for you to just play around it, see what is there, and take your time to study it, and then I'm sure you'll be fine. And then in the same packet tracer, there is what they call the simulation mode. Can you see? This is the simulation mode. We're going to come to the simulation mode in another class. When we come to do one of our labs, you're going to see the concept there. And then you will see the real-time mode. So these are just a few things you can see in packet tracer. These are routers. If I come in here, if I click network devices, you see routers that are here. If I click end devices, you see this information changes here. I see PC, laptop, server, and things like that. If I come and click this connection here, I see different network media, different cables that I'm using. I see them here, all right? When I click the folder here, I see what I get. So these are like the different categories for switches, hubs, wireless access points, see cell tower. You know, you can click and drag and things like that. Then you see it automatically connects. Now, so there's so much that you can do on packet tracer. But like I said, this is our first class in chapter 1. And we're going to, each day we take a packet tracer activity. We're going to now see what and how best it can serve us. Okay. So I'm going to be unmuting, but if you have a question, it's an opportunity for you to ask. Okay. If you have a question, it's an opportunity for you to ask. So just raise your hand up, electronic hand, and then I will take to you.
Give a sample. You give a sample that intranet is the internal network of a particular organization, like banks. But I want to ask that this intranet, people still launch attack to this intranet network to get access to the activities. So, and you said that it's not possible for someone outside to have a kind of access to the network. So how do these people, how did the attackers could launch attack to the intranet network? And what are the vulnerability access that associate with the intranet? That's my question, sir.
Okay, thank you very much. Now, like we said, intranet, it's local network. It's resources that are within your local network. And when we talked about threats, we said we have internal threats and we have external threats. Internal threats are threats that come within your organization. It's like saying in your house, somebody is a thief, maybe one of your workers or somebody that lives with you or one of your relation that is living with you is a thief. That person can be able to steal something within your house, even if you have security dogs, even if you have a gate man with an armed policeman at the gate. That threat is internal, it can still happen. Okay, but external threats we're saying is that it comes from outside. It comes from outside. So if you're having intranet, it doesn't mean that you cannot have internal threats that comes within. Okay. Thank you. The next person is Rabiu Ibrahim Abdullahi. Okay, seems Rabiu is not ready now. The next person is Kabir Murtala. You can unmute yourself. Okay, Kabir is down. Okay,
well,
yeah.
Hello, sir.
Good evening.
Yes, sir. We appreciate your effort towards the success of the delivery of the class. Yes, I want to ask, sir.
Yes.
I don't know if you are going to consider putting us through this crimping, because I can discover you are talking about cablings, and it's very germane for us to know how to crimp cables so that we can know how to connect these end devices, including the routers and the likes. I don't know if you have that in mind, sir.
Yes, I have
Crimping.
that in mind to teach you guys part of crimping. However, you know, the best way to do it is physical, but this training is virtual. So the virtual aspect is just to give you the basics and to show you how it is done. All right. But maybe when we meet physical, then we'll be able to now practicalize it. All right. We're going to do practicals. We're going to configure routers. We'll configure switches. We'll crimp cables. We'll configure firewalls. We will set up a network. We will configure the internet. There are a lot of lab activities we are going to be doing, but all we'll be doing is virtual. Okay.
Okay, sir. Thank you, sir. You're wonderful. We appreciate. Thank you, sir. Yes, sir.
The next person is Farao Abubakar Abdullahi.
Good evening, sir.
Good evening.
The name is Faru.
Oh, Faru.
Last time yes. Thank you, sir. I just want to thanks Dave for the wonderful presentation. We are really grateful. Secondly, I want to request that the WhatsApp group link be dropped here, so for people that are not in that group to be able to join for easy dissemination of information. Thank you.
Yeah, I think let me just do that.
Hello, good evening, sir.
Yes, just a minute, please. Let me just drop the. All right, so go ahead. I'll drop the link. I'll drop the link for the WhatsApp group.
Okay, good evening, sir.
Good evening. Sorry, is your hand up?
Yes, sir.
Okay,
Rabi Ibrahim.
Just okay. I called you earlier, so go ahead.
Because I was able to unmute myself so that I can talk due to the weather. I cannot be able to do so.
Sorry.
Yeah. Mine is not a question, but I just want to ask for the recording section, because due to number of incoming calls that was being disturbed on the network, I cannot be able to add some things, and it is a wonderful section that we have. And this because this is the first even the lecture that you have taken us. Please, I just require for the live section recording of it that you have done.
Okay. All right. After this class, I usually drop the recording on a YouTube link, and I have always said you need to subscribe to that YouTube channel so that each time we drop a recording, you will get a notification. So after now, I will drop the same recording so that you can be able to follow it. I'll drop it on the
Thank you, sir.
the WhatsApp group. So let me see what's group. So group. Okay, so I've dropped the link on the chat. If you are not in the WhatsApp group, you can just click the link and you'll be fine. The next person is Dr. Oho Stephen. Are you there, sir? Your voice is very, very faint. Can you increase your volume?
Okay, I think my volume is high. Are you hearing me now?
Yes, go ahead.
Okay, thank you so much for your presentation.
You're welcome.
During the course of your presentation, you mentioned you list 3 body that monitor and take care of the internet. So my question is that if we have body like this that monitor the activities of the internet, why we still have a lot of bad activities, like some of all these so-called fraudsters that still make use of this internet to carry out their nefarious activities?
Hey, I appreciate you for your question. There are certain part of your answer. If I answer now, because I have not given you some foundation, it may be confusing. So I will answer part now. The other part, when we begin to take the topics that are related to it, you will get to understand. These bodies are individuals, are people that are within the organization, different organizations that control to manage, that set policies. All they do is set policies to govern the usage. For instance, there is a body that manages what we call IP addresses, okay? And they have it in different continents. The one in Africa is called Afrinic, okay? Different continents, there's a body that manages that. There's another body that sets policies on how devices are manufactured and sets universal standards on some of those details. There's another body that deals with the structure of the internet. There's another body that deals with data. Different bodies deals with different things. Your question is about the usage of the internet, okay? And when we get to that point, I will explain to you the role that individuals play when it comes to the internet. The internet is much bigger than you imagine it to be. There are parts that you don't see. There's the open web, there's the dark web, there is the hidden, there's a lot that you don't see. So for those that may be going into security, I'm sure you will be told a lot of this. But for now, maybe I will put it there. So I'll stop here so that I don't confuse you guys with too many terms that you're not too familiar with.
Okay, like in a nation, like a nation like Nigeria, apart from NCC, is there any enacted body that empower to manage, like you mentioned, because look at it, the ones you mentioned they are outside this country. Do we have one in this country apart from NCC we are hearing of that manage the activities of the name?
Yes, you see, the NCC you are talking about is government, okay? And that is a Nigeria Communication Commission, all right? Let me see. If you look at let me say, how do I put it? There's a body called Internet Exchange Points, IXP. And IXP, what they do is that all the traffic on the internet meets at a particular point, and then it goes. Now, the government only regulates, like what NCC does. NCC just regulates what happens on the internet, okay? But the body that you are asking of, it's a global body, but can have a chapter in Nigeria. For instance, we have what we call the Internet Society Nigeria chapter. The Internet Society Nigeria chapter. There's a role that they play in the global body, and then there's a role that they play in the Nigerian chapter. It is not managed by government. Okay, the ones that are managed by governments like the NCC that you're talking about, the Ministry of Communication and things like that, all these ones they do is regulate. But because the internet is not owned by anybody, the internet is not owned by one person or something like that. One person cannot say, I hold the right to decide what happens and what does not happen. No. It is usually a coming together of different parties, because there is something that will happen. If you go to maybe China now, you see that there are certain part of the internet, like social media, some part of it is not permitted freely in some of these Asian countries. And the reason is because of the policies that their government have put in place. But that does not stop the entire global body from setting up the standards and the rules in the usage of the internet. So if you are thinking of Nigeria as a country, the agency you're talking about basically do what we call regulation. So they regulate the usage, and then they enforce certain policies that will help the usage within the country, because there is so much that is related to it. There is the role of the ISPs, the internet service providers. There is the role of the end user. There is a role of the content creators. There's a role of the network media personnel. There's a role, there are different roles. Okay. So that is it. Next person is Ahmed Makido.
Thank you very much, sir. It's Ahmad Makido.
Okay.
I have to start by commending the effort of our able resource person. Actually, I'm highly impressed the way you have calm mind and very wonderful deliberation style. You are not rushing, you are gathering almost everything. Then I have to also confess by commending the effort of making this medium of interaction. You really shows the professionality there. We can see your face, which motivated us. Beside the environment, that is the packet tracer is very obvious. We can see everything without distraction. My own is a bit clarification, or I may put it to be correction. You shouldn't mind. We are a encyclopedia of a lot of professionals in the gathering here. Like myself here, I have specialization in IoT. So somebody asked a question about topology. He mentioned prominent topologies which are star, bus, hybrid, and so on. When he asked the question, he wanted to segregate between the two, saying which one is logical, which one is physical. If I'm not mistaken, you respond to him by saying that they are physical. So the correction here is once we mention a term topology, it's just like biology, it's a Greek word. Topho means a place, logy study. So study of place has to do with network nodes arrangements. So once we are talking about network nodes arrangement, we are talking about both physical and logical. So ideally, once we said network topology, no way we can segregate the two. They are talking about how the flow of data can be achieved logically and physically because they are interchange. I mean, they are two mutually exclusive. That is why from the packet tracer, if you look at it, every topology has two physical layers, logical as well as physical. So the point of correction I wanted to point out here is all those ones he mentioned, actually they are the network topology. So the definition of network topology is that has to do with both arrangement of physical and the logical flow of the data. So if I'm not mistaken, please, we can refer back to other content and justify the talk. Thank you very much.
All right. Thank you very, very much for your input. I really appreciate it. No person is a fountain of knowledge. We're all sharing idea. Okay. So I think the little clarification here is that he was talking about the ring topology and the bus topology. And we had already established a background of the concept of physical topology and logical topology. Logical, like we said, like you rightly pointed out, has to do with the flow of the data, okay, particularly in the IP address arrangements and things like that, and then how the data flows. But in the physical topology, we are talking about how the devices are connected, okay? The arrangement, the layout of the various elements, like the nodes, like you said, the device, how they are connected physically. So if we have bus topology, ring topology, all these topologies, we can have them physical, how they are arranged, okay? And they can be different. But when you say a logical topology, you can have a particular logical topology that explains just the flow of the data. So this is just an emphasis on what he has said, and I really appreciate you for making that. And I want to use this opportunity to let the entire class know if there are areas that you think that probably we need to correct or make more clarification, please do well to let me know. Thank you very, very much, sir, for that. The next person is Abdul Hakim Ishola.
Yes. Hello, thank you very much.
You're welcome.
Can you hear me, sir?
Loud and clear.
Yes. Can you hear me now?
Yes, I can hear you.
Okay, my question is on packet tracer.
Yes.
After downloading the packet tracer and you want to start making use of it, does it work online or offline?
It works both offline and online, okay? But in most cases, it works offline. But sometimes if you've installed and you want to use it for the first time, it will ask you to log in. It will bring out like a login screen and tell you to log in or something like that. So you can log in. If you log in with your net account details, then you have access to full feature, all right? And once you log in, it keeps your login active for the next 3 months, okay? Without you necessarily need to log in, and you don't need to be online. So you can just launch it and then go ahead. So that is it.
Okay. Thank you very much, sir.
You're welcome. Sadiq Bello Abubakar.
Okay, thank you, sir. Hello, can you hear me?
Loud and clear.
Okay, I'm one of your former students since during the COVID-19 training for FBTE. Thank you, sir, for your wonderful presentation. Actually, I have another contribution that I want to add from the first person that asked about intranet.
Yes.
Intranet said, why is it like in banks, some of the attack comes from this, he said, outside. So I have some real life scenario that I want to give him, maybe for him to understand what is it like, what you have said. Yes, it's always when you see attack within intranet, most of the time is within the organization. That is within, the threat is come within. So like one of the banks, somebody is within the bank, one of the staff give the, the cleaner, ordinary cleaner, a device that he don't know what is work. He just asks him, there's sometimes in a room, they just left one of, pots, that additional pots available. He knows about the pot. He just gave him that device to plug that device in that room, maybe in just a store, one of the store, but he knows there's a pot, additional pot. So he gave him that device that he can access remotely from his own location without him knowing, the cleaner without knowing, yes, you want to launch an attack to the bank. So unless after the attack was done, later they find that, yes, somebody within the organization, they have to trace and find out that, that staff, that cleaner is the one that helped that another staff, which is one of the teller of the bank, who used the, who used the internal way, maybe account, maybe he has his access to that account. So when he plug directly to the network of that bank, so he has access from his own location. He tried to attack the bank all the time, but he caught in the process. But that is how they normally do. So looking at that, so he's within the organization, even he used the internet to launch the attack, maybe. So that is what happened when you see the attack was done, maybe from outside or to the bank. They said they have an attacker that used to attack to their own networks. So that is what I want to insert on his question. So I just want to put my own understanding with your own, explanation. Thank you, sir.
Thank you very, very much. I always appreciate when you make comments, you contribute, or maybe you correct me where I'm wrong, or you add knowledge to whatever we have said, because others may gain the experience. So the point I think of emphasis here is that threats can be both internal and external, and internal is even more dangerous because you have access to devices and things like that.
Thank you, sir.
So thank you very much. So I think we have exhausted the hands now. Our time is almost up, so it's time for us to take our attendance. So before we take our attendance, I want to thank you very much for being part of today's class. We look forward to meeting for the next class, which is going to be on, I think, Saturday, if I'm not mistaken. And please do well to subscribe so that you can get the notification. I have also done recording on network basics. For those of you who are new in the networking environment, I'll also drop the link again on the WhatsApp platform so that if you want to follow up to network basics for beginners, you can actually get that. So thank you very much.